Hello and welcome to a chapter on wide area networks. So in this chapter we are going to cover all the different types of technologies that interconnect LANs together because that is what a WAN is. A WAN is the interconnections. Please write this down just as we start. WAN is the interconnections of two different LANs that are, of two LANs that are located in different geographic areas, and they need, this is important, they need an ISP to enable them to connect. So we'll be able to discuss the different topologies, how they are connected, compare the characteristics of WAN technologies, depending on the throughput, media, security, reliability, and we'll talk about um, some WAN connections such as ISDN, the T carriers, frame relays, all the different types of offerings that a service provider will tell you, will offer you. Um, and we'll get into some of the objectives, and we'll talk about the WiMAX, the satellites, and so on. So let's get started. We already wrote the definitions of what a WAN is. So when you have two LANs that are in different geographic areas and you want to connect them, there is the option of having there. If you go to a service provider and you tell them that you have another branch that you want to connect to, let's say you are located in New York and your other branch is located in Dallas, Texas, Dallas, Texas. So they are going to allow, they're going to give you two offers. They're going to ask you to either you can go public or you can go private. That's what the ISP will offer you. If you're going to go public, that means you want to use the internet to connect to Dallas from New York. And if you want to use the internet, you must create a VPN, a virtual private network to connect. That's the least expensive way. And to be honest with you, most people would rather use the VPN because the security is there and it's the least expensive way. This is what it comes down to. The only problems with VPNs is they are prone to denial of service attacks. So for whatever reason, you may not have access to whatever you're going to. But in terms of security is not a problem. And you got to make sure that you are connected. Since you're already paying for the internet, so might as well use it to connect to the other resource. All you need is a VPN concentrator, an appliance on both ends, and then you'll be able to connect. You'll use the internet to connect to the other side. The way it works is you're going to take your packet, you're going to encrypt it, and then you're going to tunnel it, which means re-encapsulate this encrypted data with another packet. Only the both ends will be able to decipher the tunnel and the encrypted data, the payload that's inside that tunnel. That's what a VPN is, a virtual private network. It's as if those two sites, New York and Dallas, as if they are connected right next to each other on their as if they had a directly connected wire. But it's virtual because you're going over the internet and through the tunneling. So that's that. If you prefer to do that, by the way, it's very easy configuration, no big deal. We'll do that in our CCNA security class. We'll be able to configure VPNs on even allow the routers to do that. More security, nobody will be able to see if anybody's eavesdropping on the internet and watching your data. They won't be able to see it. They'll be able to see it, but they won't know. Even if they get inside the tunnel and find out and trying to see your data, it's encrypted. So it's almost impossible to really, find out what you are transmitting. So security is there, and it's very hard to bring. But they can stop you from going to your destination. The denial of service may be an issue. If that's the case and you still need connection, then they will offer you to go privately. Now, to go privately, that means you have to pay a fee. Privately, companies, you have to pay a service provider a fee to connect you to your destination. So there are three different options when you go privately. By the way, please write this down. The WAN, you either can go public. On the public side, just write down that you have to go through the internet. And if you're going to go through the internet, type right underneath the internet, you're going to use VPN. And on the other branch, if you're going to go privately, there are three choices. The first choice you should write is dedicated. The second choice should be circuit switching. And the third choice should be, excuse me, packet switching. Now, under dedicated, I want you to write down examples of dedicated is T1 lines, like a T1 line, which we'll discuss in a few minutes. Under circuit switching, you want to write down ISDN or dial-up. Under packet switching, there's a whole bunch of them. There's frame relay, there is SONET, SONET, there's ATM, there's cable modem, there's a whole bunch of other frame relay. I did mention frame relay. All right, so those are your options. Privately means you have to pay a fee for them, and then they'll connect you. Dedicated is the most expensive, and the least expensive is packet switching, such as frame relay or ATM or any of those other options. MPLS, for example, which we'll discuss in a few minutes. All right, what's the difference between a LAN and a WAN? Please write this down as well. LANs connect nodes. LAN is what connects hosts together inside an area, inside a LAN, inside a broadcast domain. WAN connects these LANs together, but specifically if these LANs are far apart from each other and you need an ISP to connect you. And the ISPs are like AT&T, Verizon, Comcast, and so on. Okay. The individual geographic locations connected by a WAN, that's the WAN site. The link is that connects the two LANs together. Now, if your device, if your router does not communicate with the outside world, it doesn't have the capability to communicate with the outside world, it's called a DTE, a data terminal equipment. If your router is able to speak to the outside world, then your router has a DCE device, a data communication equipment. So if you're directly connected if you connect two routers together, one of them is a DTE and one of them a DCE. It's the DCE that sets up the clock rate to allow them to communicate. The DTE doesn't have the capability to set a clock rate. A clock rate that is set on a DCE tells the DTE device how fast data is going to be transmitted and received. You must do that when you are connecting directly connected devices with each other. One of the devices must have a DCE, and it must enable the synchronization, the clocking, the clock rates. All right, so please write down DTE is a data terminal equipment, and it's a customer endpoint device on the WAN. The DCE is the carrier end device. He's the one that sets the clock rate. So if you're directly connected to your ISP, the ISP is the DCE, and you're the DTE. It's the ISP, the one who sets up the clock rates. All right, so here's your connection to the internet, and you have all of these different branches. They want to connect to the headquarters in Miami, for example. So all of these could be WAN connections. LAN is the interconnections of hosts inside a LAN, right? This is one LAN, so it could be in San Francisco. And then they go to a router to connect to another LAN that's in Miami. Here's your DCE devices. DCE devices are like modems or CSU, DSU devices, anything that a DTE device that's inside, like the router, they send the data to a DCE device like a modem to set you up so you can communicate with the outside world. All right, so the DCE device is like your NIC on a PC. Your PC without a NIC is considered to be a DTE device, a data terminal equipment. But if it has a NIC, then the NIC is a DCE device. That's the data communication equipment to allow you to communicate with interface with other devices. But we say data DCE is specifically to communicate and interface with other devices in a WAN. In a LAN, we call it a NIC. In a WAN, we call it a DCE device. All right, WAN topology. How do you connect them physically? So, for example, if you had a headquarters somewhere, like in the previous illustrations, we had a headquarters in Miami, and you have branches all over the country. How do you want to connect them? You can connect them in many different ways. You can use a bus topology. That means it is used, for example, like this. Everybody's connected straight to each other. So data will go to this, the carrier street, Watertown, then you go to Main Street, then you go to South Oak Street, right? And they're only connected. That's a bus topology. The advantages of a bus topology is required if you have a small WAN, maybe 2 or 3 offices, 2 or 3 branches that you need to connect. It's not scalable because if it starts to grow and you have more branches coming in, it's not feasible to really have one connections to connect all these different branches all over the country. It's not feasible, becomes impossible to deal with. You may use a ring topology. This is used typically in a metropolitan area, a MAN, within a city limit, and it uses what's called the FDDI, the Fiber Data Distributed Interface. So if it'll be a connection like this. Typically it's done with dual rings. So you'll have 2 connections to each site, and one ring would just be sitting idle, and the primary ring is where all the data is flowing. So if the primary fails, the other one takes over immediately. And it's all fiber, very fast connections. You're talking about gigabit connection, and everything's wonderful, but it's expensive, of course. Star topology is what's the most common, but because what typically is done, you have the headquarters is located in one place, and everybody comes to the headquarters. That's where all the resources are. But the problem is, this is where the central point of failure is. If the headquarters, for whatever reasons, you have no access to it, then all the branches will not have access as well. So here's your headquarters. Everybody connects to the headquarters, but that's typically, believe it or not, that's the way it's connected. And if you use VPNs, you can use VPNs to connect to the headquarters. There's always will be a connection. That would be to eliminate the central point of failure. You can always use a VPN to get to your headquarters and to gain access to whatever resources that you need. You can use a mesh topology if you want that to really eliminate the central point of failure, right? So if this link breaks, there's always a way to get to the central point, to headquarters using a mesh topology. But a mesh topology meaning you're going to have some dedicated lines or DSL lines that are just going to be sitting idle, not doing, and you'll be paying a fee for them. Maybe you will not pay, depending on what your agreement with your ISP, unless something goes wrong. So they'll have some sort of redundancy, a backup. Maybe you'll only pay for it when something goes when you use that line. And I think a lot of ISPs do that. They want to offer your redundancy so that you can have the connections, the uptime. Remember we talked about that? You want the quad 9s, 99.99% of uptime. Tier topology is also used. It's scalable, and but it's typically used in a LAN design. So this is where you can have a whole bunch of different headquarters, maybe, I guess, and then for each headquarters, some people can connect to it. So if this headquarter could be the engineering of the company, this is where the sales, this is where the productions, and they can have their own site. So if you have a whole bunch of different salespeople, technologies, they can connect. That's where most of the resources are. So these people for the sales, that's where they connect. Engineering, different depending on what type of engineering. This is the headquarters for them. And you may have also a core on the top where everybody connects to. You could do that too. Uh, it's easier to manage, scalable, grow without compromising, more secured. I like the tier topology, and I teach that in a LAN and in a WAN environment. If you need to design anything from scratch, you you do it in a tier topology method where you have core distribution and access layer design. All right, so let's start talking about the options, the different services that you are offered by an ISP to connect two or more sites together that are in different geographic areas. So the public switched telephone service, PSTN, or sometimes we call it the plain old telephone system, 98% of the whole world is connected through the plain old telephone system, the analog connections that people can communicate with. It's all analog traffic that's going back and forth. There's plenty of old analog telephones still in existence. Maybe not around where you live, but it's still out there. You can use it to make phone calls. You can use it to actually connect to the internet. Like we've discussed earlier, you have to modulate the data to be able to connect to the internet, and but it's extremely slow. Um, Local loop. Local loop means, here's what I want you to know. The connection that you pay for, let's say you pay for 100 megabits connection to Comcast. You're paying for the data that leaves your modem to the central point, to the central office switch. That's called the local loop, or sometimes they refer that as the last mile. And once you get to your ISP at 100 megabits per second, then they take their data and they throw you on the internet. And then you go to your destination. They're not responsible what happens to you on the internet. You know, the internet is an unregulated interconnection of multiple lands publicly. It's unregulated, nobody's watching it. A lot of bad stuff can happen on the internet. So therefore your ISP and you yourself have to protect yourself and filter out all the data that's coming off the internet, right? And making sure that, you know, you hide yourself if you're going to use the internet to get to another destination. All right. Here's some other terminologies. NIU, the network interface unit, is the termination point at a customer demarcation point. So, for example, your cable modem will be your NIU. So the demarcation point means this is where the customer responsibility ends and the ISP responsibility begins. This is typically what connects you to the outside world. So if anything happens outside your house, it's the responsibility of the ISP. Anything inside your home, then it is your responsibility in terms of equipment or connections. So if they have to call a tech to come into your house to figure out, or into your organization to fix the problem, then it's your responsibility. So the demarc point is, you know, states where the responsibilities of the customer and the service provider. Fiber to the premises. FTTP is what Fios offers you. A fiber connection all the way to your home. The main difference between Fios and cable also uses fiber, but when they connect you from the pole outside your home, wherever your connection is, to your house, that's usually coax. But once you get to that trunk outside your home, It's all fiber to be able to carry that kind of bandwidth. But Fios offers you fiber all the way into your home. So there is no coax cable connection and you get pretty good speed. But it's going to cost a little bit more, obviously. The passive optical network is the carrier uses fiber optic cable to connect with multiple endpoints. So here are the topologies for a passive optical, the PONs. Here's the fiber to your home. So this is the ONU optical, and they connect the coax cable. This is something similar to the coax. This guy has coax. These have fiber directly connected to their home. Okay. All right. Let's talk about the T carriers. T carrier technology is a T1. I want you to understand. Here's a couple of things I want you to write down under the T carrier technologies. Number one, T1 is made up of 24 DS0, digital signal 0. Number two, DS0 equal 64 kilobits per second. So 24 of them is approximately 1.544 megabits per second. That's the T1 line. It's a dedicated connection, which means the sender and the receiver use a physical wire no one else will use. No one. And if you're not sending or receiving data, no one is going to be using it. So it's a dedicated connection. Number three, they will use the way you frame the data that you are sending. You use PPP, 3 Ps, the point-to-point protocol. That's how you frame them. We'll discuss how that and how to set up the connections in a different class. How to configure two directly connected devices. It uses TDM if you're on the trunk. The data time division multiplexes, which we discussed previously. All right, so here's your DS0. DS1 is 24 of them, gives you approximately 1.44, and you have a whole bunch of different types of T's, fraction T's, so they call them, and so on. So you can get T5 and you can get close to 400 megabits per second. But remember, because it's dedicated, this is an option, one of the privately connecting options that an ISP can offer you. But it's expensive because, you have a dedicated wire to your destination that no one else will use except you. So you're going to be charged a lot. But it's the most secure. You're guaranteed no one else is going to be using it. It's managed by your service provider and it's there for you. The speed may not be as good, believe it or not as good as a VPN, and it's much less expensive, of course. All right, so that's that with T1s and T3s. T3 is 28 T1s, by the way. They give you a T3 line is 45 megabits per second. So T1 is 24 DS0s, which gives you 1.5 megs. T3s is 28 T1s tied together. That gives you 45 meg. All right, wiring of a T line, a T wire, a T1 wire. So if you remember with the T1 connections, you can use with a unshielded twisted pair cable or a shielded twisted pair cable. You can use coax, microwave, fiber, however you want. But if you're not connecting it, a T1 line out to the outside world, you want to use, not an RJ45, but an RJ48 connector. Just remember you are transmitting at pins 4 and 5, and then 1 and 2 you receive. So that's how you would create a T1 cable. If you remember with Ethernet, we use an RJ45 connection, and the transmitter is on pin 1 and 2, and the receiver is on 3 and 6. So it's a little bit different, right? Here's the crossover. Remember, pins 1 and 2 has to be connected to 4 and 5 on the other end if you're going to cross over for a T1. Now, from your devices, you go to a smart jack. This is like your modem. So customer demarc point is called a smart jack. So please write this down. This is like for a T1 line. So you take your devices, you connect to a smart jack, and from that smart jack, you go to the outside world. That's your demarc point. All right, CSU, DSU device. See, a channel servicing unit, data servicing unit separates two devices together or combines into a single stand. This is also could be used for a T1 line connection. All right, so here's a typical incoming T carrier. So here's a CSU, DSU device, connects to a smart jack, and then connects to a T1 connection. So you would need something like this to enable you to connect to the inside your LANs, the typical connection. All right, you don't have to write that down. I thought I was thinking about allowing you to. Don't worry about it. Anyway, the DTE is typically a router, a data terminal equipment that does not communicate with the outside world. So please write this down. This is important. This way you'll know what a DTE is. Translates the network layer protocols and directs data to the destination. This is really within the LAN itself. It does not communicate with the outside world at all. It's connecting to a CSU DSU device to accept data from outside. All right. So here is the CSU DSU device, and here's your data switch. You can communicate with whatever you want. You send your data to a CSU DSU device, and that CSU DSU device will connect you to the smart jack, like your modem, to go to the outside world. If you have a public PBX with your telephones, you also can connect that to a CSU DSU device. Will allow you to do that. All right. It would be nice if you can actually write this down. You don't have to. You could draw little boxes to connect these, because I want you to know a smart jack connects to a CSU, connects to a LAN. From the smart jack, from the CSU, just draw a line to a data switch and also draw a line to a PBX. So this drawing, you don't have to do the drawing, just connect lines between them, but I want you to understand that's how the connection for a T1 line connection would be. Okay, another option, which is a legacy nowadays, is frame relay. It's not really in use. What I want you to know about frame relay is that it's private. That's number one. Packet switching technique that it uses. Okay. It offers you a CIR, which stands for a committed information rate, so they can guarantee you a specific speed. So throughput, so they can say, okay, we can guarantee you 2 megabits per second, no matter what happens. You can burst, which means you can go faster, and typically it's free if no one is using the links, but we'll guarantee you a certain rate. Better secured, more security. It uses something called the DLC, the Data Link Connection Identifier, which is stamped on the frame depending on where you are. Depending on what your data link is, you'll go from one frame relay switch to another. It's faster than routers because they do not open up the frame to look inside the frame. They just read the DLC number, and depending on the data link connection identifier, you are relayed from one switch to another. So please write this down in terms of the DLC. It's an identifier. It's not routers, by the way. It's switches. Identifier routers reads to determine which circuit to use to send the frame to. So it is really um, like a number that is stamped on the frame. So when the frame relay switch, here they call them a router, reads them, they figure out which path you're going to go instead of looking at the IP address like a router would do. It's connection oriented. It's going to make sure that you are connected before they send data to the receiver. It supports a switch virtual circuit and a PVC, SVC and a PVC. Please write this down. There's two types of virtual circuit. Switch virtual circuits is connections established when power is needed to transmit, then terminated after the transmitted is complete. PVC, that means the connection is established before the data needs to be transmitted and are maintained after transmission, which means really in PVC you always take the same path to the destination. SVC means you can take different paths to get to your destination. Typically you want PVC all the time. So if you ever need to configure a frame relay, it's preferable that you always use PVC. So you know which connections, and this way you can offer the committed information rate, right? So the advantages of having frame relay, you pay only for the bandwidth that you're going to use, how much you want, what kind of guarantee bandwidth. It's the least expensive, but I'm telling you, it's old. We're talking about megabits per second connection. So it's dead, to be honest with you. And you're not, I very doubt that when you get into the when you get into the field that you were going to service any or deal with any frame relay switches. Very doubt it. But, somewhere outside North America, I don't know. Maybe there's still some around. I've heard there's plenty of them in South America somewhere, but I don't know, depending on where you're going to end up. All right, the digital subscriber line, DSL line. Couple of things you want to know, write these down, is about DSL. DSL is used over the plain old telephone system. The PSTN operates. You have to be within a certain distance to get connections. I think within like 6 miles from a switch, because otherwise they won't be able to get connections. It's directly connected. Once you directly connect it to the switch, so once you get that certain amount of speed, that's over the telephone wires, and it's digital. It's all digital. Your throughput doesn't fluctuate, just like like cable modem, right? But the speed is not that great, to be honest with you. That's why cable really takes over, and this is one of the reasons why FiOS opted for, when they went with, Verizon went for FiOS, and even with FiOS they stopped doing that because it got too expensive. And where I live, Verizon offers FiOS for half of the city, and the other half, if I need to go with Verizon, they can only offer me DSL. And DSL, speeds in the single digits of megabits per second is not acceptable nowadays. So cable is my only option. I can't wait till we see, we get the 5G, so we have some competition with this cable. So at least we'll have something different to do, I'll have some options that I can work with. But anyway, data still has to be modulated to use the telephone wiring system. There are different types of DSL. The most common is the asynchronous DSL. This is the most widely offered. So write this down. ADSL means you're sending data the speed of sending data upstream and downstream are different. So typically the down is you have a lot higher bandwidth given to you on the downstream than the upstream. Typically, when you're getting on the internet, especially for home use, if you're getting on the internet, you're clicking on few links. That's the upload, and that's kilobits per second. But on the download, they can offer you megabits per second because you're downloading images and web pages, and maybe you're streaming something or whatever it is. So you need a much higher bandwidth. That's asymmetrical. So the X is for the A, the G, the H, the S. Synchronous DSL is something typical to the like T1 line. The upload and the download is the same speed. Super high speed DSL we're talking about in megabits per second. That can get close to 100 megabits per second. G Lite is for quick connections. Okay. All right, so that's we just discussed the symmetrical and asymmetrical. Modulation is you still have to modulate the data to get the higher frequency because they send you data, by the way, voice and data on the same wire with DSL. Okay, so please write that down also. DSL offers data and voice on the same telephone wires, but then they separate them. So what you need is you need to also write this down. You need to put a filter for the incoming data when you are connecting it to a phone, so you can filter out the data. Do not put the filter when you're connecting it to a PC. In other words, the wire comes in from outside. When you want to go to a phone, you've got to put a filter before it goes to your phone. If it goes directly to your PC, if you're connected to a PC, do not put a filter because otherwise you're filtering out the data. That's, by the way, the most common issue with DSL customers, because when they send them the package and they tell them to do a self-installation at home, and when they see the filters, they start putting the filters for every device that they connect at home. Then they call in the Verizon techs and they tell them that, the phone works, but, I cannot connect to the internet. 50% of the time they were telling me that, people will put a filter or they use the filter to connect before they connect it to the PC. And you cannot do that. All right, so very high speed DSL can give you 52 megabits per second, right? But you have to be within 1,000 feet. Asynchronous DSL, which is the most commonly used, you'll have a TCP connection. I mean a control transmission protocol connection. You'll need a splitter, right, for voice and data. And that's it. That's with and here's the DSLAM. Here's the splitter when it comes into your home. Well, this is the splitter when you come in your home. Here's your DSL modem. So you will put a filter here and do not put a filter here, right? You get your DSL modem, and this is your DMARC modem. This is typically maybe done at your home. The tech will come in and install this to your home. So you just connect to your DSL modem. Just make sure you put a filter here. And that's it. You're good to go. You're connected. You get data and voice. No video. Video, you have to call someone else. A different service provider. Cable modem? Well, cable can give you up to 100 megabits, much faster speed than DSL. It can also offer you video. So we're talking about video, data, and voice over IP, over a cable. The cable can over 100 megabits per second. So what they do is they reserve certain bandwidth for voice and certain bandwidth for data and certain bandwidth for the video. The disadvantage of cable is that trunk that runs in your neighborhood, because it's only has a certain amount of bandwidth, and they're sharing that bandwidth. If everybody connects to the cable, your throughput is going to fluctuate depending on how many users in your neighborhood are connecting. With DSL, that doesn't happen because you're directly connected to the DSLAM, to the multiplexer, No one else will be sharing those wires, but it's a much lower speed than cable. So cable throughput fluctuates, but typically, even though it fluctuates, you get a higher speed. Um, Here's a typical cable modem. They can use the hyper fiber coax. Um, all right, so that's that. With asynchronous ATM, ATM, here's what I want you to write about ATM. It functions at the data link layer. It's a layer 2. So in other words, you can actually take out an Ethernet switch, replace it with an ATM switch, change the NICs to ATM switches, and you get much faster speed. And you have an ATM network. Simple as that. Also, it is used preferably for um, voice and um, real-time communication, such as video, because of its speed. Number 3, I want you to write down as it can give you speed up to 622 megabits per second. And it's also not only for a LAN, it's used for a MAN, M-A-N connection, not a LAN, typically ATM. And it uses a 40, the packet or the cell, we call it, write this down, is 48 bytes plus an additional 5 bytes for the header. Very small, 53 byte cells. When they, in comparison to Ethernet, which is 1,518, 53 is much smaller. So they can move very, very quick. That's why it's almost impossible to get a delay, because no matter where you're going, the incoming device will be able to process a 48 data byte, a 53 byte cell. So you'll move much, much quicker to get to your destination. That's why they can offer you up to 622 megabits per second. And they do offer quality of service as well. All right, so and typically it's in the MAN connection, not a WAN, really. You don't go within a city limit, let me put it that way. All right, so they can offer you from 22 to 622 megabits per second, but it's expensive though. WiMAX, it's wireless for WAN connections. You may want to use that. FDDI, you may want to use that, and the price is not that much. So ATM is really dying out if it's not completely gone. So that's also a legacy protocol. The synchronous optical network is the most expensive, but it also gives you the highest speed. The bandwidth is almost unlimited. So please write this down, the key strength, the 4 points for SONET. WAN technology, it interoperates with everybody. It connects, in other words, T1s with all telephone lines. You can go into a SONET and you can filter them out much quicker. Fast data transfer rate, simple link additions and removal, and high degree of fault tolerance. They take care of them. If there's any misconnections, you can also reconnect much quicker without you getting involved. It must be connected in a ring, so write that down, just like the FDDI. And it's not really typically for organizations. SONET is mostly used for service providers to communicate with each other, because they have a tremendous amount of data rate that they have to transfer from one location to another. So for example, Verizon maybe want to send data to Bell South. They may use a SONET connection to transfer all of these data. The internet is all fiber, and we're talking about, 3-digit gigabit connections between each other. The data rates are usually indicated by the optical carrier level. Here's a typical, by the way, SONET multiplexer. where you can take multiple different types of connections and connect you to your destination. So you can have DSL, T1s, regular router connection. It could be frame relays, regular old, and it can all put you on the ring, connect you, and the connect and picking up the data to a T1 line. It doesn't matter what you're mixed up with. They'll be able to pick up their data much quicker. So once you're on the wires, you're going extremely fast, and you can easily get your 1.544 megabit connections. So different types of connect. That's what it really used for. Different types of connections connecting to a fiber. But again, it's expensive. Now they can offer you an optical connecting level one. That's a 51, and then it becomes multiples after that. So OC3 is 3 times 51. That's how much you get the 155. OC12 is 12 times 51. That's how they get 622 megabits. So depending on what kind of bandwidth you want. So if you decide you want an OC 768, you're going to get close to 40 gigabits per second connection. And there's a whole bunch of them out there too. All right, the multi-protocol labeling switching, MPLS. All right, so write these points down for MPLS. It's extremely fast. It can handle various types of payloads. Something similar to frame relay. It uses a shim, like a label on the frame, and it moves data much quicker, even much quicker than frame relay. Very, very fast connections. So ISPs love to use them. So often ISPs on their own networks, they use MPLS connections. It's more, if you work for an ISP, there's a very good chance you may be configuring MPLS networks. So this is becoming more and more popular because of its speed. There is the Metro Ethernet. That's also another big thing. If you are within a metro area, you can use the the Metro Ethernet. All right. So this is as long as you are within a city limit, you can get gigabit Ethernet connection, which is wonderful because most likely inside your LAN you have an Ethernet connections to go outside. You still be working with Ethernet. You don't have to switch to a different protocol. The speed is enhanced. But the only problem with Ethernet is the limited distance. But with gigabit Ethernet, the Metro Ethernet, you can get 40, 60, even 160 megabits per second connection. But you have to be close enough that the wires can reach you. So we're not talking about very far with Metro Ethernet, by the way. Write this down. A MAN, Metropolitan Area Network. You have ATM in there, FDDI, Metro Ethernet, and WiMAX. Those are the offerings that you can have as long as your connections, your LANs are within a city limit, a metropolitan area. So with Metro Ethernet, you have streamlined connections. It's much less expensive, scalable. Everybody's familiar with it, of course, because this Ethernet is, 99.9% of LAN connections are all Ethernet. So it's much easier to configure and connect. When it becomes wireless, you can have the WiMAX, the 802.11. So please write this down with my WiMAX. So write all of these points down for the 802.16. You have the line of sight transmission between two antennas for the use of fixed clients. So you have to actually see the antennas that you're transmitting. The frequencies you can operate between 2 and 11 or 11 and 66 gigahertz. You can use licensed or unlicensed. They use MIMO, multiple in, multiple output, multiple antennas. You can actually transmit up to 30 miles with fixed antennas. So that's pretty good. 30 miles. This is even a little bit past um, a city limit. But we're not talking about going, if you go beyond 30, it's almost impossible. The only problem with it is it's not portable, which means if you pass this 30 miles, you have to reconnect. It's not like the cellular connections. If you're driving in your car, you're handed from one cell state from one tower to another, and you don't even know that you've been handed it out. With WiMAX, that doesn't if you get out of yourself, you have to reconnect. You have to re-authenticate, which is a problem. This is probably one of the reasons why it's not growing as fast as the cellular connections, is because of the portability. All right. But it's still expensive. The equipment is expensive. That's the problem with WiMAX. But it's still out there. When it started out, they envisioned that they want all the WANs. Just imagine that everyone is wireless, and all of these wireless, they wanted them to make them portable, so you can travel from any place you want, and you'll get your voice, data, and video, and interconnect and be connected to the internet. But what's going to kill this now is the 5G. 5G is going to have 20 times faster than the 4G. So, and it's going to compete heavily and probably be a lot less expensive than WiMAX. So WiMAX will disappear when the 5G kicks in, because you have the portability, you have the speed, and it's going to also compete with the LAN inside your home. So it's going to be a standard that's going to take you from inside your home and to the outside, and you're on, one protocol that covers everything. The only other thing that I think will still be around is the WiMAX. So it's going to be WiMAX, your old routers at home, and 5G outside, and everything will be. That's where everything is moving. It seems like, and a lot of companies are spending a tremendous amount of money on that. So, which is good. Easy, you're dealing one or two with two protocols, but you still have to go, all of this is wireless, but you still have to go on a wired eventually. So these wires may be fiber connections to your destination or whatever, you know. Uh, in a LAN, you may still, the good thing about being wired is you get the speed um, and the security because you're bounded. Wireless, you may still have the different combinations of wired and wireless in an enterprise environment. All right, so that's that with WiMAX. The new WiMAX is still um, competes, but with cellular data services, it's not going to compete with the 5G. Okay, when it comes to cellular, the 1G is all analog. That's in the early 1990. It was crackable. It was funny. You were able to just capture the data that's in the airwave, um, reconfigure another phone, and be able to, steal data, steal phone connections, and be able to communicate with someone else's phone as if it was that you know, till somebody gets his bill, and we, and everybody will, that person will just figure out, and he wasn't calling China for 500 hours last month, and he has to call the service provider and tell them somebody was able to steal his connections. Because all you had to do is just scan the airwaves for about, I think, for 800 megahertz. That's what it operated on. Capture all the data, the serial number, the phone, everything, and then just go take that information and configure another phone with it, and you can use that phone to communicate with anywhere in the world, and it's open. Till the early 1990s, when CDMA came in and it became digital, that's where the 2G is, that killed it all. And then 3G operated up to 380 kilobits per second. That's just, that's in the early 2000s. And now I think we're operating with 4G in the LTE networks, the long-term evolutions. and that gives us a pretty good, close to 100 megabits per second, which is not bad. You can get a gigabit for slow-moving clients. So please write the 1G, 3G, 1, 2, and 3 and 4G's networks. And also, I want you to know that GSM, what it stands for, and what CDMA. GSM is not only what it stands for, it also uses TDMA, time division multiple access, which means multiple users will use the same channel to transmit data, but they share the bandwidth at very fast speed. CDMA, they use a code to transmit the data. They don't share time. Okay? I think Verizon uses CDMA, GSM, AT&T. I think even Verizon now switched to they also offer you GSM. This way you pull your SIM cards and so on. The cellular connections for CDMA, in the old CDMA, they can offer you 622 users can connect to a one tower. TDMA with GSM, usually the tower can handle close to 400 or less. That's theoretically. But now it's the more towers you have, of course, the more users you can use on the cell, but it costs money to put up a tower. All right, so that's that. That's the cell that I'm talking about. And they are portable. That means you can go from one cell to another without any problems, without having to reconnect. WiMAX, you have to reconnect. All right, satellite. Satellite is when you have a satellite on top and you can have digital video, digital TV, radio signals, voice, cellular connections, data connections. We can use it for our GPS systems, you name it, right? It mostly uses the geosynchronous Earth orbit satellites, or satellites that operate, that stay over the Earth. So as the Earth turns, they stay with them. All right. Most satellites are like this. So they just turn with they send them far enough so that the force that's pulling the satellite will keep the satellite moving along with the Earth. So you'll be on top of, let's say, North America the whole time. And there, once you are far enough, so the pull is not that great, so you don't have to have a lot of fuel to offer, to keep the satellite up there. Actually, it uses the sun as fuel, so it can stay up there for years. And you just need the fuel to get it up there, to get it far enough from Earth, so that the force pulling it is not that great. The farther you are away from Earth, the less force needed to pull it. You have transponders that are up there that you can send data and they can point down to Earth. So here's a typical satellite. Here's the transponder. And by the way, GPS works exactly like that. They know where you are. They'll send a signal to you, and you'll have a map written, and that signal, and that map with the picture shows you exactly where you are. Right? The GPS was done for the military, but now you can use it to find your way home. Right? So there's plenty of, the Earth. I mean, the Earth is bodied with there's satellites all over. And they are from every country has their own satellites for the TV, data, voice. It's the easiest way to connect. You don't have wires, you shoot the data, and the transponder will, on a specific frequency, will send the data to its destination. And there are a whole bunch of different frequency bands. There's the L, the S, the C, the KU, the K, and the KA bands, depending on the frequencies. The higher the frequency, the more data that you can send. You can have internet connections with satellites. It's very expensive. Of course, This is really if you are somewhere in a desert or in a rural area that you have no connections whatsoever, your only option is probably satellite to connect to the internet, but it's a little bit more expensive. All right, when we come to troubleshooting WAN issues, there are some steps that you need to connect before you're calling your ISP. Make sure that all the connections inside your LAN is operable. Typically, the first thing I would do is ping the default gateway. Make sure that it can connect if you are at home. And if you can ping your default gateway, then most likely the connection is outside. What's typically done, just to let you know, a lot of times they send updates and they change things on your ISP will do that, and that will clog up your modem. And what you need to do if there's connections, just disconnect the cable modem and your router, and then connect after 10 seconds or so, reconnect the cable, turn it on. Don't turn your router on, and then you turn your router on, maybe 10 or 20 seconds after the cable modem boots up. And most of the time it will work fine. Otherwise, just wait maybe, and you'll get, for whatever reason, maybe the link is down. So you have to call your ISP if the link doesn't come up after a day or two. It could be something else that you're having problems with. ISPs usually can throttle data for you, depending on who you are and how much you're paying. That's true for cellular connections too. They can block certain things that you're not connecting. They really don't track your data or who you connect to or download or upload. I guess if you're doing something really illegally, um, and they may, the government may ask for who is downloading certain things or what you were doing, so they may get subpoenas. I think they probably would be able. You could be tracked regardless to a specific public address. That's why you should not let anyone really use your address, and you should secure your wireless network, because if somebody taps into your wireless networks and uses your connections to do illegal stuff, and if they need to find out who is doing it, it's going to be your IP address that they're going to come to. All right, anyway. Common ISP problems, you need, it could be anything that the service provider is doing, upgrading, and things like that. But they typically do it early in the morning, maybe after 2 a.m. and on the weekends where no one really needs the connections. That's where they do their upgrades. And that may create an issue. And if that happens, you just have to reset your modems. So you'll need to check out the NIUs, the line drivers, the CSU, DSU devices if you are in an enterprise network. Issues to look for, common interface errors that comes up, routing loops, you cannot connect because packets are looping back and forth because something is down, or maybe a specific protocol is not operating correctly. Router misconfigurations, maybe got the wrong IP address or the protocol that's running to connect. In other words, if you're connecting on a T1 line, you should use PPP as the protocol, not HDLC, which is the default, because if the other end is using PPP and you're not using it, you're going to have misconnections. Excuse me, DNS issues. If the DNS is down or somebody attacked it, you won't be able to type your addresses to connect to your destination. And maybe there's interference, especially if it's wireless. Find out where you are. Where's your access point that you're transmitting? Is it near an electromagnetic interference device? You have to look for that. All right, so that's that with the WAN chapter. Please write down everything that I told you to and submit that as homework. And we will meet again on another chapter. I'll see you then.